Hello, Year 10 5.3 Mathematics students. Today we are continuing on with the topic of probability and we're learning about using tree diagrams. So tree diagrams can also be used to help list outcomes for 2-step and 3-step experiments. Suppose that a bag contains 2 red counters and 1 blue counter, and that 2 counters are selected at random with replacement. So one way to display the outcome is a tree diagram in which equally likely outcomes are listed in columns as shown in method 1. So this is method 1 here. Or we have that a more efficient way, however, is to group similar outcomes and write their corresponding probabilities on branches as shown in method 2. So in method 1, we have our blue counters all through here and our red all through here. So we have our outcome of red, 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 blue, red, 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 blue, blue, red, blue, red, blue, blue, like so. And we have calculated that they all have the same probability, and they all have the probability of 1/9. So that means the probability of red-blue, well, there's 2 of those. So red-blue occurs here, and it also occurs here. So the probability of red-blue is 2/9 because it occurs twice. Or we can do our more simplified method of method 2, where we have our red on one of the branches, we have our blue on the other branches, but we write these probabilities here on our branches that tells us that 2 out of the 3 are red, 1 out of the 3 are blue. And when we have with replacement, the probabilities will stay the same. So we'll then have our red, red here, red, blue, blue, red, and our blue, blue. But we find that the probability of red, red is 4 out of 9 that it occurs. Our probability of red then blue is 2/3 times 1/3, which equals 2/9. Our probability of blue and red is 1/3 times 2/3, which is 2/9. And our probability of blue, blue is 1/3 times 1/3, which is 1/9. And our probability of red then blue is 2/9, which stays the same, but we find it from this simple bit here. So doing it through method 2 just makes it a lot simpler and a lot easier, especially when our tree diagrams get more crazy. So in method 2, the probability of each outcome is obtained by multiplying the branch probabilities. This also applies when selection is made without replacement. So tree diagrams can be used to list the sample spaces for experiments involving 2 or more steps. Our branch probabilities are used to describe the change of each outcome at each step. The probability of each outcome for the experiment is obtained by multiplying the branch probabilities, and the branch probabilities will depend on whether the selection is made with or without replacement. So for experiments with replacement, the probabilities do not change, and for experiments without replacement, the probabilities do change. So let's have a look at some examples. So suppose that 2 selections are made from a group of 2 male and 2 female workers to complete 2 extra tasks. We want to complete the 2 tree diagrams to show how these selections can be made both with and without replacement. So first we're going to look at with replacement. So we have choice 1, we have our females and our males. So our females is 3/5 and our males is 2/5. So if we replace them, this means that our probabilities are all going to stay the same. So that means that this probability here is going to be 2/5. So then we have our choice 1 is our female or our male, and then choice 2 we can either choose a female or a male again, and our probabilities stay the same. Oh, and sorry, I made a typo up here. That's meant to be a 3. So then our outcomes here, we can either have female, female, we can have female, male. Here, if we follow our branch along, we have a male and then a female, so MF, or we have a male and then a male, so MM. Now, to calculate the probability of our outcomes, so for our females, we know that that's 3 over 5 times 3 over 5, which equals 9 over 25. So all we've done is we've multiplied our branches together for our female. For our female-male, we again multiply our branches together. So we go 3 over 5 times 2 over 5, which equals 6 over 25. So for our probability of our male-female, we want to multiply our branches together. So that's 2 over 5 times 3 over 5, which equals 6 over 25. And for our probability of our male-male, we want to multiply our branches together. So 2 over 5 times 2 over 5 equals 4 over 25. And that is our probability tree with replacement. So then for our tree without replacement, I'm just going to zoom in to make it easier for you to see. So for choice 1, we either have female or males. So we know that our males, there is 2 out of 5 of those that we have at the moment. So then from our females, we can either have, for choice 2, we can have females or males. But now, because we have without replacement, because we have taken a female out, we now only have 4 left, 4 people to choose from. So because we've taken somebody out of the mix, there's only 4 people to choose from. So now we have 2 out of 4 females, so we'll have 2 out of 4 males available. So then going down here for our choice 2, we have a male, so then we can either have a female or a male. And so we have taken a male out of the mix. So now we only have 4 people to choose from in both cases. So we are going to have, for the females, we've taken a male out of the mix this time. So there's still 3 females left. So we write 3 over 4. And so for our males, we've taken 1 out. So there's only 1 left. So then our outcomes, we have female. Here we have female, male. Here we have male, female. And then here we have male. So again, to get our outcomes, all you do is you go along your branches to get your female. Okay, and now our probability. So to find our probability, what we have to do is we have to multiply our branches together. So for our first probability of female, we multiply our 3/5 by our 2 over 4 to get 3 over 10. So for our probability of our female-male, we'll multiply our branch of females times our branch of male here together. So we'll go 3 over 5 times 2 over 4, which equals 6 over 20. So that is our probability there. So then to get our branch of our male-female together, we'll multiply our male by our female here. So we're going to go 2 over 5 times 3 over 4. So 2 over 5 times 3 over 4. So that equals 6 over 20. And then we want to get our male. So we have our 2 over 5 branch times our 1 over 4. So 2 over 5 times 1 over 4 equals 2 over 20. And so that is our probability done. We can simplify these. So this here would be 3 over 10. Again, it would be 3 over 10. And this one here is 1 over 10. So you should simplify them when you do that as well. Okay, moving on to example 2. We have boxes A and B contain 4 counters each. Box A contains 2 red counters and then 2 green counters. And box B contains 1 red counter and 3 green counters. So a box is chosen at random and then a single counter is selected. So what is the probability of selecting a red counter? So we want a red counter from box A. So probability of red counter. So red counter from box A. So in box A, there is a total of 4 counters. There's 2 red and 2 green. So it's going to be over 4, and the number of red that we have is 2. So our probability is 2 over 4, which equals 1 over 2. So then what is our probability of selecting a red counter from box B? So the probability of a red counter from box B is equal to, so in our box B, we have a total of 4 because we have 1 red and 1 green, and we only have 1 red. So our probability is 1 over 4. Now we want to represent the options available as a tree diagram that shows all possible outcomes and related probabilities. So what we're going to do is, what you think about is we have to select a box first and then a counter, because we're going to choose which box we put our hand in before we pick which counter we get. So what we're going to do is we're going to start here and we're going to draw our lines. And so these are going to represent our boxes. So this is our box, and we either are going to choose from box A or box B. And so the probability of choosing from these is there's only 2 outcomes to choose from. So it's just going to be 1 over 2, because we can either choose box A or box B. So the probability of those is 1 over 2. And then we're going to pick our counters next. So in box A, we can either choose a red or a green counter. And now the probability of our red counters in box A, from part A, we've calculated this, and it is 1/2. And so that means that because we want these to add up to 1, because our probabilities always add up to 1, the probability of a green counter from box A is also going to be 1/2. Then from box B, we can either get a red counter, or we can get that didn't work too well, or we can get a green counter. And we know that the probability of selecting a red from box B from part B is 1 over 4. So then the probability of selecting a green must be 3 over 4. We then have our outcome that we need to write down for our tree diagram. So our outcome in our first one is we could go box A red. So we're going to write in brackets A and then red. Then our second outcome is A green. So we write, helps if we go back to pen, A green. Then our third outcome is B red. So again, we write B red. And our fourth and final outcome is box B counter green. So we write B green. We then need to calculate the probability of this. So we need to multiply our branches together. So for our outcome A red, we need to multiply our branch A, our box branch, and our counter branch. So we need to go 1/2 times 1/2. So 1/2 times 1/2, which is equal to 1 over 4. So our probability of getting a red is going, from box A, going to get a red is 1/4. Then we need to, for our outcome A green, we need to multiply 1/2 by 1/2 again. So that is going to be 1/2 times 1/2, which also equals 1/4. So our probability for our box B red is 1/2 times 1/4. So that is 1/2 times 1/4, which equals 1 over 8. And then our probability of 1/2 times 3/4 for our outcome B green. So 1/2 times 3/4 is 3 over 8. Now, if you ever want to check that you've got your probability correct, you just have to add your probabilities together and they should equal 1, and that's how you know you've got it correct. Now, what is the probability of selecting box B and a counter red? So we want to box B and a counter red. So box B, counter red, that's this outcome here. And so the probability of B and then red, we calculated up here already for us, which is an 1/8. Now we just want to work out what is the probability of collecting a red counter. It doesn't matter which box it comes from. So because it doesn't matter what box it comes from, what we want to do is work out where all our red counters are. So our red counter is here, here, here and here, sorry. So it doesn't matter, we just want it to be a red counter. So we'd go our red counter, so A red, so it's going to have a probability of a quarter, and then B red, which has a probability of an 1/8. So we're going to add those together. So probability of 1 red, so we have a quarter plus an 1/8. And a quarter plus an 1/8 equals 3/8 in our calculator. Moving on. So for example 3, we have a bag contains 5 blue and 3 white marbles, and 2 marbles are selected without replacement. So we want to draw a tree diagram showing all outcomes and probabilities. So our first selection is going to be either choosing a blue or a white marble. They're the things that could occur. So selection 1, we could either choose a blue or a white marble. Now, if we just represent our blue marbles and our white marbles up here by these dots, we have 5 blue and 3 white, where we have a total of 8 marbles. So if we were to select blue, we could select 5 out of 8 and they would be blue. If we selected a marble and it was white, we could select 3 out of 8 for it to be white. For selection 2, if we first choose a blue marble, we can then choose for selection 2 a blue or a white marble. So if we choose a blue marble, because we aren't replacing it, so we've already chosen a blue marble, so let's cross that out. So that means that we only have 7 marbles left. So these are going to be over 7. And because we've already selected a blue marble, there is only 4 marbles to select from that are blue left. And there is 3 white marbles to select from the 7. If we already have chosen a white marble, then we can choose in our second selection either a blue or a white. And so because we have already chosen a white, that means that we only have 7 marbles left to choose from. And we have that 5 of them are still blue. And we have that only 2 of them are white. So now let's write out our outcome. So our first outcome could be, following the branches along, blue, blue. Then we could have blue, white. So blue, white. Then we could have white, blue. And then we could have white, white. So these are the selections we could have, or our outcomes. So now let's have a look at their probabilities of these outcomes. So the probability of a blue, blue is 5/8 times 4/7, which equals 20/56, which simplifies down to 5 over 14. For our outcome of blue-white, it has a probability of 5 over 8 times 3 over 7, which equals 15 over 56, which simplifies down to staying as 15 over 56. For our white-blue, it has a probability of 3 over 8 times 5 over 7, which has a probability of 15 over 56. And this stays the same as 15 over 56. It doesn't simplify down. And for our probability of our outcome white, this is 3 over 8 times 2 over 7, which is 6 over 56, which simplifies down to 3 over 28. So now we want to find the probability of selecting a blue marble followed by a white marble. So that means that we want it to be a blue and then a white. So a blue and then a white, we have calculated that out over here, and we have calculated that to be 15 over 56. So the probability of a blue and then a white marble is 15 over 56. Now to find the probability of 2 blue marbles, so that would be the probability of blue, that is our top probability or top outcome of blue, and so that's 5 over 8 times 4 over 7, which is 20 over 56, which equals 5 over 14. So our probability is going to be 5 over 14. And then we want to find the probability of exactly 1 blue. So the probability of 1 blue. So that's going to occur when we have our blue and our white and a blue. So we're going to have to add these probabilities up together. So our 15 over 56 plus our 15 over 56. So this equals 15 over 56 plus 15 over 56. So it equals 30 over 56, which simplifies down to 15 over 28 in our calculators. For part C, we have if the experiment was repeated with replacement, find the answer to each question in part B. So with replacement, I'm just going to quickly draw a tree diagram over to the side so that we can then work this out. So when selecting objects with replacement, the number of marbles in the bag remains the same for each selection. So that means for our first selection, we would have blue and white, and so that will stay as our 5 over 8 and our 3 over 8. And then our second selections are going to have the same probabilities as our first selections for our blues and our whites and our blues and our whites. So that's 5 over 8 over 3 over 8 and 5 over 8 over 3 over 8. So that means for blue, it's 5 over 8 times 5 over 8, which we can calculate. For blue, white, it equals 5 over 8 times 3 over 8. For our white, blue, it is 3 over 8 times 5 over 8. And for our white, it is 3 over 8 times 3 over 8. And so these equal to 5 over 8 times 5 over 8 equals to 25 over 64. 5 over 8 times 3 over 8 simplifies down to 15 over 64. 3 over 8 times 5 over 8 is 16 over 64, and 3 over 8 times 3 over 8 is equal to 9 over 64. So that would be what our tree diagram looked like with replacement. So I know it's something else that you have to add on your page, but it really will save you time answering these questions over here, and it doesn't take up much of your time. So now we have a blue marble followed by a white marble. We want to find the probability of a blue and then a white. So when we do that, our probability of a blue and then a white would be blue, blue, which is 5/8 times 3/8, which equals 15/64. So that is equal to 15/64. Our probability of 2 blue marbles, so blue, blue, that is up here. So blue, blue is equal to 25/64. And the probability of exactly 1 blue marble, so that is our blue, white, plus our white, blue. So that's our 1 blue is adding them together. So 15/64 plus 15/64 equals 30/64.